and welcome guys to the Gate Alike channel. Now we are going to discuss about DBMS functional dependency concept. First of all, what is data? We hear around our surroundings that this is data, data is very important. What is data? Data means a raw information. Generally, data is not helpful. Information is important. Information are nothing but meaningful data. For example, a road, a car, a bus, this is all the data. But the data is not helpful. A road is there at that place. A road is there in Hyderabad. This is information. This information is helpful to our needs. From this information, we will make records, especially database records. These database records store the information of the data in the form of records or tuples. With these tuples or records, we generally perform operations such as updation, deletion, insertion on these database records, which is helpful for our convenience or needs. Now we are going to discuss about RDBMS model. Data stored in the form of tables is called relational database model. For example, take this example and understand the RDBMS. This student is a database model, and this is the roll number, name, branch, gender, CGPA are the attributes, and this is a tuple 1A, CS, female, 9. So rule number 1, name is A, branch is CS, gender is female, CGPA is 9. Like that we made 4 rows, 4 tuples. This is called the RDBMS model. In RDBMS model, data is made in the form of tables, and each record is a form of information. Now let us discuss about functional dependency. What is functional dependency? Let us say x, y. This means y is functionally dependent on x. You generally know about the father-child relation. Child generally depends on father. The same way here also, x tends to y means y is functionally dependent on x. Now These functional dependencies are of two types. Trivial functional dependency and non-trivial functional dependency. First, let us discuss what is a trivial functional dependency. In trivial functional dependency, let us say y is functionally dependent on x, then that means y should be proper subset of x. Let us say AB tends to A. This is a trivial functional dependency. A is proper subset of AB. You seeing right like this. Now ABC. Now if you observe this, AB is proper subset of ABC. These are all trivial functional dependencies. Now let us discuss about non-trivial functional dependency. In non-trivial functional dependency, let us say y is functionally dependent on x. That means x intersection y should not be equal to 5. This is the case. In this case, there should not be anything common between x and y. Let us say AB tends to DEF. This is a non-trivial functional dependency. DEF. Here I should keep equal to, I think. Equality is over. And let us say another example. This is a functional dependency. This is the non-trivial functional dependency. Now take this table as an example and now check how many non-trivial functional dependencies are actually satisfying this table. Now let us first check P to Q. P to Q, P is 6, Q is 6, P is 6, Q is 7. For one value of P, there is two value of Q. So this is not possible. This function dependency is not true. Let us check P to R. 6, 7, 6, 7, 7, 4, 8, 4. For each and every value, there is a different value. So this is possible. So while checking non-trivial functional dependence of a table, first remember one thing. Either the relationship should be 1-1 relationship, or it should be many-one relationship. It can't be one-many relationship. Now check this relationship PR 6, 7, 6, 7. This is 1-1 relationship. 7, 4, 8, 4. It is also 1-1 relationship. It is many-one. Maybe that is also true. So PR is valid. Now let us check P to QR. 6, 6, 7, 6, 7, 7. It is 1 to many, because if you look at it, 6 to 6, 7, and the same 6 to 7, 7. It is one value. It is combined with many values of the other relation attribute. This is not possible. So if in exam anyone gives you a question that how many functional dependencies are valid, so generally check either it is 1-1 or many-one. If it is anyone satisfying these strings, then that is valid. If in any relationship one main relationship came, that is not the valid non-trivial function dependency. Now let us discuss some additional rules of the functional dependencies. First, the functional dependency should be reflexive, transitive, and augmented. Now let us discuss about some additional rules of the functional dependencies. Reflexivity, transitivity, augmentation, union, decomposition. First, let us discuss about reflexivity. What does reflexivity says? If x tends to x, y depends on x is a functional dependency, then y should be super subset of x. This is the important point of the reflexivity. Let us say a, b, c tends to a. Here a is super subset of a, b, c. So it is a reflexive relation. Now transitivity. Let us say alpha to beta and beta to gamma are two functional dependencies. Then alpha to gamma also exists. This is transitivity. Now let us discuss about augmentation. What does augmentation says? Let us say alpha to beta is a functional dependency, then alpha gamma to beta gamma is also a valid functional dependency. It exists. Now union. If alpha to beta and alpha to gamma are two functional dependencies, is a valid functional dependency. Alpha to beta gamma is a valid functional dependency. We can join the functional dependencies attributes which are on the RHS part of the same functional dependency attribute which is on LHS part. Beta gamma can be joined. This is union. Now decomposition. Decomposition is nothing but the alter welt, the opposite of the union. Simply, if alpha to beta gamma exists, you can say valid, then alpha to beta, alpha to gamma are also valid. This is our decomposition.